Okay, so yesterday we simplified radicals. And so it was just if they were perfect squares, if they were in our perfect square list, then we just found the square root either in our head or in the calculator. If they weren't in the list, then we found a number in the list that divided evenly into it, preferably the biggest number, and then we broke it down and then simplified it from there. Today is going to be very similar, except all of these numbers that are under the square root are negative numbers. And that's not something you've ever had to deal with before. So that's brand new for you guys. So, what happened a really, really long time ago is there were some mathematicians that were frustrated that an equation like this didn't have a solution. So we haven't solved equations like that yet. But if you guys were going to take this equation and solve it for x, what would you do with that one? If you wanted to solve it for x, what would you do with that one? Subtract it. Good. So you would get that x squared is equal to -1. So can you think of a number that you can square and get -1? Well, -1 squared is actually +1. That would give you -1, but when you square something, you multiply it by itself. So that's good thinking, though. But there isn't a number that you guys know about, a real number, that you can square and ever get a negative. So what they did is they invented a number, and they call it I, which is called the imaginary unit. And I is always going to be equal to the square root of -1. Right, so anytime we have the square root of a negative, your answer is technically going to be considered an imaginary number. And I know it's weird and it's really hard to be motivated to learn about something that's imaginary. I know. But imaginary numbers are used by astronomers or physicists to figure out stuff like inside of a black hole. So I don't know if any of you guys are pursuing that. Probably not, but that's okay. It's okay to learn something that you might not specifically use, but all of you in your life are going to have to think, problem solve, not give up when things get hard. So I know even though this doesn't feel super applicable, it is in general. Like understanding math and learning math is definitely going to help you in whatever you end up doing. So anyway, whenever we have this square root of a negative, you're going to have an I, you're going to have an imaginary number. And so today we're going to only be talking about pure imaginary numbers, and they're of the form BI, where B is a real number like 2 or -7 or 8 or whatever, and I is the imaginary, and this is a typo, is the imaginary unit. All right. So what I want to do is go ahead and make that list of perfect squares across the top, just like we did yesterday, unless you want to flip back and forth. So we're just going to start with some perfect squares. So we're going to start with 1 squared, 2 squared. Just keep squaring the next number. always forget 14 squared, 196. Okay. We're going to use that list exactly like we did yesterday. So today is going to seem super similar. There's just going to be one little extra thing we have to do, and that's dealing with the negatives. All right. So on number 1, we want to find the square root of negative 9. Oh, sorry. All right, so we want to find the square root of negative 9. So I'm going to show you like mathematically why this works. And then after this example, we're just going to kind of just do it and not have to do it mathematically. So what I'm going to do on the square root of negative 9 is break this apart to the square root of 9 times the square root of negative 1. So what is the square root of 9? Just 3, good. All right, and then I just told you the square root of negative 1 is going to be I every time. So that's I. So the square root of negative 9 is just 3I. Okay, so I probably won't do this every time, like break it apart, bless you, with the square root of negative 1. I'm just going to know that if you're doing the square root of a negative, you have to put an I out there. And so it sounds kind of gross, but what I tell my students to do is if there's a negative under the square root, you're going to pull out an I. And when you pull out an I, then it becomes a positive under the square root. And so if you guys look at our list, 196 is in the list. What's the square root of 196? 14. And so the square root of negative 196 is just 14i. Right. And same thing on the next one. So I see that it's the square root of a negative. So I'm just going to pull out an I and make it the square root of a positive. Now, 1 is a perfect square, but breaking it down, like simplifying it, trying to use 1 won't help. So if we're looking at the numbers in our list, other than 1, is there a number that's going to divide evenly into 5? There isn't. So we're just going to leave that as I square root of 5, and we're done. We don't have to do anything else. All right, let's look at the next one. All right, so we have the square root of negative 80. So I see there's a negative under the square root. So I'm going to pull out an I, and then I'm going to make it the square root of positive 80. Now there are a couple of numbers that are perfect squares that are in our list that divide evenly into 80, but we always want to find the biggest. So we'll make it easier for us, and we'll definitely get it right if we find the largest square that goes evenly into 80. So it has to be less than 80. So we're looking at numbers about right here. We want to find the biggest one that divides evenly into 80. So we can just take 80 in our calculator and start dividing them by numbers that are in that list. 16. 80 is 16 times 5. So we can break it down into the square root of 16 times the square root of 5. Right. And then yesterday I said that the perfect square can break out of the radical prison. And so when 16 breaks out, what does it change to? 4. The square root of 16 is 4. So do you guys think you would do I4 or 4I? 4I. So we would write this as 4I square root of 5. So just like if you had 2 times x, you wouldn't write that x2, you would write it 2x. Same thing with the I. All right, let's look at number 5. Bless you.
What's up with like on number 2 you get like 14i,
Uh-huh.
but these other ones you have the I in front.
Okay, so I have I in front of the square root. So 196 was a perfect square. It was in our list of perfect squares. So whenever I simplified it, I didn't have a square root. But this one, I had to break it down. And so typically what you would do is write the square root last, and then the 4i goes in front. All right, same thing for number 5. There's a negative under the square root, so I'm going to pull out an I and then make it a positive under the square root. Okay, and then we're going to look at our list of perfect squares and find the largest perfect square that divides evenly into 32. What do y'all think? There's 2 of them. 4 does, but there's actually one that's bigger than 4 that goes evenly into 16. So we can break 32 down to 16 times 2. Okay. All right, and then just like the last one, this is very similar. The square root of 16 is 4, so we're going to write 4i, and then the square root of 2 we would write last. Okay, and then on number 6, I see there's a negative under the square root. I'm going to pull out an I and make it a positive under the square root. All right, now 192 is not in our list, but there's actually, I think, 3 numbers that divide evenly into 192. So start with the bigger numbers. Okay, nice. So 192 is 64 times 3. All right. And then because 64 is a perfect square, it can break out of the radical prison. And when it breaks out, you actually find the square root of 64, which is 8. So this is going to be 8i square root of 3. All right. And there's one more thing we're going to do today with I. So down there's like a break between the tables. Just remember that I is equal to the square root of negative 1. So if I squared both sides of that, what do you guys think I squared equals? So when I square I get I squared. What do you think you get if you square the square root of negative 1? You get negative 1. Whoops. Negative 1. So anytime you have I squared, you're going to change it to negative 1. All right, so we're going to do 4i times 7i. So we would multiply 4 times 7, and that's going to be 28. Right, and we multiply I times I. That's going to be I squared. Right? And then anytime you have I squared, you change it to -1. So what do you guys think this should be?
Wait, hold on.
-28. It's okay. So let's say that you have 5i squared. What do you think that's going to be? If I squared is just -1. What do you think 5i squared would be? It'd just be -5. Good. What if you have -20i squared? What's that going to be? Just 20. Nice.
What if it goes like I like more than square?
We're about to do one like that. I'm going to keep it like if I can get a squared, I'm going to keep it a squared. But I can have a higher power than 2, and it changes from problem to problem. Oh, we're going to do one kind of like that. So anyway, anytime you have the I squared, it just changes the sign of the number in front of it. Okay, so we're about to do what he talked about. So we're going to multiply these two together. So -4i times 2i is -8i squared. And then I'm going to hold off on that -9i for a second. So what is -8i squared? Good. All right. Then I'm going to take that and I'm going to multiply it by -9i. So that final answer is going to be -72i. All right. So we're going to skip 9 and 10. So I just multiply these two at a time this time.
So can you just like multiply them all together and just change the set to -7?
Well, if you multiply them all together, powers of I is something that's kind of hard to understand. You would get that. You would just multiply them all together.
You just like change it.
And so what you would have to do is understand that that's the same as I squared times I. Actually, if you multiply them all together, you get positive 72i cubed. So you need to know that I cubed is I squared times I because you add the exponents. And then you would make that I squared a -1. And you get the same answer. So if you understand that, that's fine. I think that's kind of hard to understand, but maybe not. All right, so let's hold off on 9 and 10, and let's skip down to number 11 because this is a pretty common thing that we have to watch out for. So we can't just multiply these together the way they are to get, and if you did, you would just get the wrong answer. So anytime there's a negative under the square root, we're going to pull out an I and make it a positive under the square root. So we'll do that for 18, and we'll do that for 10. So just pull out an I and make it positive. All right, so then we're going to multiply I times I. What are we going to get? I times I. I squared, good. Right, and then when we multiply these, since they're both under the square root, we can multiply them together and get 180 under a square root. Now I already know that I squared is going to be -1. And then I want to find the largest square that divides evenly into 180, which is 36. 180 is 36 times 5. And And then the 36 can break out of the radical prison and change to 6. So I still have that negative 6 square root of 5. All right. We're going to do one more. This is going to be another one where we have more than 2 i's. So we'll figure it out. All right. So same thing. I see that each one of these has a negative under the square root. So I'm going to pull out an I for each one. All right. So this is what I'm going to do. This might not be the best way, but I know that I times I is I squared. So I'm going to go ahead and write that as I squared. And then I'm going to multiply that by another I. That is kind of weird. Right. And then for the square root, I'm going to do 24 times 3 times 2, which ends up being 144. Pretty sure. 24 times 3 times, yeah. Okay. Yes. So I squared is negative 1. I is I. The square root of 144 is 12. And then to write this in the right order is exactly what he said. It's negative 12i.
What would you do if they're not like that?
What do you mean?
Like if they weren't square.
If it wasn't a perfect square, we would do it like we did these up here. You'd break it down, find a square that goes into it. So the negative came from this negative 1, and the square root of 144 is 12. So you want to write that in front of the I. All right. So your assignment